Hey guys, we are in the basement, and today guys, we're gonna do a John's Arcade tech video, and I guess kind of a restoration, because guys, yes, it's true, this is part number 2 of the computer space restoration. And here it is. Here's our 1971 Nutting and Associates Syzygy computer space. And yes, guys, this right here is the very first commercial video game ever. And in this video here, we're gonna start working on it. Because in the last video, we picked it up, really. And Adam and I kind of screwed around with it a little bit in the garage, trying to get it to work. And we swapped out the power supply with a modern one, and we couldn't get it to do anything. So really, this is the first, I guess, tech or restoration video. And my plan is this. And by the way, I'm a little nervous. I'm not gonna lie here. I'm a little nervous. I'm a little scared. Okay. So, but what the game plan is this. Okay. I want to start removing variables, okay? Because we have a television set in there. It's an old GE tube, like literally a vacuum tube television set, okay? We have a power supply that we know is not working correctly because we tested it with Adam last time. And then we have a board set that I don't know if it is working at all. So what I want to do is I want to systematically go through this game and just start removing variables, and we're going to start in this video because really this is the best way, I think, for me to tackle this project, is to just start removing variables, okay? And I got some stuff, some tools to help us along the way, and tools that I've never used before. I have a logic probe, okay, that Ian Kellogg sent me. Never used one on my own. I don't really know, but we're gonna try in this series here with this. Toth Wolf on the John's Arcade forum helped me put together a little power supply rebuild kit for the computer space. So we might rebuild that in this video here. And then also, I want to find out if the television is working, because I have no idea if the TV in that thing is even working. Because right now when we turn it on, we just have a white screen, okay? And I don't know if the television is working at all or if it's broken. I have no idea. So what I thought we'd do in this video, start out here, is I want to put a signal, a known good signal, to the television and see what happens, okay? And yes, if you look here, I have my NES out, okay? And so the plan is this, okay? So the television that is in the computer space is a GE, again, it's an Adventurer 2 television, except they modded the television, okay? Because normally, if you'd want to, you know, hook up an old game system to a TV like that normally would have a tuner, you would connect it with RF, you know, radio frequency, which is like how the Atari 2600 worked, and also how the NES worked, unless you used the composite outputs on the side, okay, right here. And so here's my plan, okay? So right here I have composite out, video, and then the audio right here. So what we're gonna do is we're gonna use the composite out of this to hook up to the General Electric television to see if it's working, okay? Because we know the NES is working, because right here we have a picture, and yeah, that's Kid Nicky. Did you guys like Kid Nicky? I actually loved this freaking game. Should we play a little Kid Nicky? So the plan is this. And by the way, I've never hooked up my NES to an LCD like this, and it kind of looks okay. Let's see. God, I love this game. You know, this is also an arcade game. But anyway, the plan is this. So since they modified the General Electric TV to bypass the tuner, it's now looking for a composite video signal. So that means we could not hook up a 2600 to it. So what we're gonna have to do is use some kind of a composite video, and I thought we'd use the NES here, and what we'll do is we'll use the RCA cable, which has composite video, it has signal and ground, and we'll use that to hook it up to the television set to see if we get any kind of picture at all, because if it does work, it should work with the NES, because we know the NES is working, and I don't know if the computer space PCB is working. But yeah, I used to play this game a lot. This is a really solid game. You know, I've always been looking for the Kid Nicky JAMA board too. It kind of looks okay on my television. Maybe I should permanently mount a console down here and get like an EverDrive cartridge or anything. But anyway, okay, we're not here to play Kid Nicky. So what we're gonna do is we're gonna use the NES to generate our composite video signal, and we're gonna hook that up to our old GE Adventurer television that is in the computer space. And mind you, normally you would have to use RF to hook it up to the tuner, but because they bypassed the tuner, it's now looking for composite video, which this thing here will generate. So what we're gonna do is we're gonna bring the NES over, and by the way, this is not my original NES. The one I had, the one that I bought when I was like 15, got sold at some point at one of my parents' garage sales. And about 15 years ago, somewhere around there, I started missing my NES. And so I picked this one up at a garage sale, again about 15 years ago. And when I picked it up, it was flaking out. So I replaced the 40-pin connector that's in there. And that was one of the first kind of moddy type electronic hands-on things I've ever done. And so it's been reliable since, not that I'm using it all the time. But anyway, yes, this is my NES. So, all right, so let's bring this over to the computer space. And we're going to hook it up to the TV, and hopefully we see some Kid Nicky on that black and white television set. You know, it's funny, because I remember back in the day, like, you know, when the 2600 came out, you know, that thing could do color, and it could also do black and white games. And so some people had black and white televisions, and some people had color, and the thing would work with either or. And same thing with the NES. I think I always had a color TV when I had my NES, but I know at some point I saw the NES running on a black and white television at somebody's house. I don't know, but it should work, and we'll get a signal. It'll just be black and white. All right, so anyway, let's go over here. Here is the computer space. I know, isn't it just badass? So this thing has such a presence about it. It's just, it has to be working soon. So, and yes, I have my little out of order check back tomorrow sign on here. I guess we can remove this for now. And so you can see in there, that is the GE television. They put a bezel around it to kind of hide the guts of the television. Right now I have the little computer space bezel, or marquee, whatever you want to call it, that would normally go right here and hide the controls of the television. That is off right now. It's on my shelf. But when we're all done, we'll replace it, and you won't be able to see those controls. So anyway, let's go back here, and let's see what's going on, okay? So here is the inside of the computer space, and it's a little scary. It's a little daunting, but I think we can get through this. So, okay, so let's take a look of the lay of the land here, and let's talk about what's going on with this thing. So, right here is our original General Electric Adventurer 2 TV. It's a 19-inch television set, I believe. No, I think it's 15. I'm sorry, it's a 15-inch TV. And actually, I picked up another one of these TVs on eBay. So if we really get stuck, I also have this one over here, which is also a GE Adventurer 2 TV. However, this one is a 12-inch, I think, or 11 or 10 or 9 or something, but it's not the full 15-inch that we need, but it's my understanding the chassis on this is the same. And yes, this is the one that Ed Freeze and I were both bidding on eBay. And I want to tell you guys that Ed and I were communicating when the auction was ending, and Ed said he didn't want it and he was going to back off, so I bid on it. So here it is, okay? So if we get stuck, we can use this. The thing is, though, we're going to have to perform the mods on this television set because the original computer space, again, they bypassed the tuner, okay? So this stuff doesn't work. And so the video signal is kind of hardwired to the chassis, I guess, after the tuner. And so it just kind of forces the signal on the screen instead of going through the RF, okay? All right, so anyway, again, GE Adventurer 2 television. You can see right here, this is where the connections are made to the TV. And if we look up here, okay, it kind of explains the connections, okay? And again, this is modded. This is not how the TV was from the factory, okay? So this screw is video input, this screw is sound input, and then this screw right here is common, okay? So if we were to look here, same deal, video signal, sound, and then common or ground right here. So what we're going to do is we're going to take our RCA cable, our composite cable out of the NES, and we're going to put our signal wire right here and then the ground right here, and then we should get a signal, okay? And again, they modded this television. They're using the UHF and VHF terminals back here to do stuff that this was never intended to do, okay? They have sound coming here and video signal and ground. So we need to forget that this says UHF and VHF because, again, they're just using these terminals to run these screws from the board. And then on the back here, these wires are going somewhere completely different on the chassis that GE never intended, okay? All right, so that's the TV. The first thing we're going to do is hook up the signal, and we'll do that in a little bit here. But I also just kind of want to review this stuff, okay? Now, this is the original power supply, okay? And it has a fan on here that is seized up right now. It's not spinning at all, okay, to keep it cool. This is an off-the-shelf power supply, okay? This is something that they found back in the day to use with this game, and I believe it only outputs 5 volts. Now, when we were testing this, Adam and I removed these 2 wires, which were hooked up here, And I have to review the video to see how they were hooked up, but I believe it was positive here and negative here, okay? And what we did in the earlier video was we hooked these wires up to a modern 5-volt, or to a modern switching power supply on the 5-volt terminals, and then that 5 volts from the modern supply came down here to our board, okay? But it is my intention to use the original power supply, because I know that Ed Freeze tried using a modern switching power supply and he had trouble with the sound because it was noisy. So I don't know. And there's not a lot of parts on here. So Toth Wolf on the John's Arcade forums helped me put together a little rebuild kit here, and he ordered the parts for me, and I have those parts. So we're going to shotgun this and see if we can fix this and get this thing to have 5 volts again. And then I'd like to figure out why this fan is seized up too. Is this something we could take apart and clean? You know, are the bearings just seized up? And this looks like a modern PC fan, but it's not. This is a true 1971 fan right here. That is the right fan. It's as old as the game. It's original. That is the original fan. And then over here we have our 3 board stack. Okay. Again, this is the original boards. I don't. You know, one board's like the video generator, one's like the logic. I don't know. We're going to learn this as we go, guys. And I want to stress here, you know, I don't know what I'm doing. I really don't, but I just want to dive into this. And I think the more time I spend with this, and the more we test things and start removing variables, I think we're going to get our head around this quick and soon enough. But it's not going to happen until we do it. And that's what we're going to start in this video right here. You know, because guys, you know, I'm not an engineer, you know, a lot of this stuff doesn't make sense to me, you know, but, you know, I got some common sense here, and I think we can get through this. And maybe this becomes a community event where we all kind of talk about it on the comments or on the John's Arcade forums, because I'm all ears, guys. You know, if you've got ideas for me, I'm all ears, okay? But anyway, looking around here still, you're just identifying everything that we have to mess around with. Well, there's a coin counter here. We don't have to mess around with that. Here's our transformer here that is outputting various voltages, AC voltages that then go to our transformer here. That's then step down to 5 volts DC. If we look inside here, and yeah, by the way, the whole cabinet is made out of fiberglass. Isn't that crazy? And if we look inside, you know, we have a old like paint can. You know, that's the coin box. You know, when you drop a quarter in there, it lands into that like paint thinner can. And then inside the cabinet, you know, there's not a whole lot. There's nothing on the bottom. Hopefully, there's no like mouse surprises for me down here. No, there isn't. So. You know, this game was in the garage all summer. You know, anything is possible. But it looks relatively clean. I should probably vacuum it out. And then up in here is the control panel, wiring and the bulbs and all that stuff. And we're going to worry about that stuff much, much later, you know, because I really want to see, I want to see computer space on that TV. You know, that's our priority here. So anyway, let me plug the game in, and I'll show you guys what it's doing right now. And right now the logic board is not getting power, and I'm just going to leave it like that, okay? So this thing is going to be trying to output voltages, but they're not going to go anywhere because the voltages are disconnected from the logic board. I'm okay with that. So I'm going to go ahead and plug this game in, and let's just, again, take a look at what it's doing, because I don't think I've plugged it in since the summer, I believe. So let's plug it in. All right, so it's plugged in. Trying to remember if there's a power switch or something here. There's an interlock right there. Oh, on the back there's a there's a on-off switch. Let's turn it on. Oh, look at that! Hey, the fan's working now. Look at that! That's crazy. That fan was not working before, and now it's working, and it sounds good. Well, that's crazy. All right, well, that's a bonus. I mean, I still want to take it apart and clean it up. So anyway, you can see here, our tube, our TV has come to life here. All these tubes are glowing, okay? Now let's go to the front and see what's happening. Okay, so we just have white raster, okay? And that's it, all right? And if we look at the control panel, you know, all these buttons are lit up: fire, missile, thrust, rotate left, rotate right. I mean, and by the way, let's just stand back and look at this thing in awe, because that's That's how I'm feeling right now. I'm looking at this, I'm like, holy cow, this looks badass. We need this in the basement. Oh my God, what a piece of history. It's the first commercial video game ever. Oh my God, look how cool that is. All right, let's not get sidetracked. So, all right, so let's come back here. So we have white raster. You know, this television might be working, guys. I have no freaking clue, you know. So all right, let's come in the back here. So I'm gonna turn it off, okay? And now we want to hook up the NES and see if anything happens on the front there. Boy, I gotta tell you, I'm pretty jazzed that that is working. That fan is working, which is really weird because it was not working the last time we turned it on. Huh. Maybe it was just a little seized up and now it's freed itself, okay? Okay, so I've been thinking about how I want to do this. Because I guess we can remove the video signal from the PCB. I don't even know if it matters. We could probably just leave it on there. So I think what I'll do is I'll remove the original video signal right here, just so we're not backfeeding video to the board. I'm sure it doesn't matter, but I'm just gonna remove this, okay? And I just wanna remove one wire, and then we also have the ground here. I think I'm just gonna leave the ground where it is, okay? And then we'll leave the sound where it is, okay? Now, we don't have any power going to the PCB, so I'm not really worried about any of that. So there's no sound, there's no possible sound or video coming through here because the power is disconnected to the PCB. So, okay, so we got that. So I have my NES over here, okay, right down here. Now, on the NES, again, I'm using the composite video out right here, and I have an RCA cable in here. See, it says video. Because NES, you could do composite or you could do RF, because in the back here, they have the RF switch, which is how I did it back in the day on my old color TV. I had it through here, going to the NES RF switch that then connects with the coaxial or antenna on the back of the TVs. But we're going to use the RCA composite video here, and I have it on the black, okay? And then what we're going to do is we're going to hook this up to our television set using some alligator clips, okay? So I did some research, and the signal wire is in the center, and then the ground is on the outside, okay? So I got some alligator clips, and what we'll do is I'm going to hook up the fat green alligator to the signal, okay? Let's go like that. And then I'm going to hook up my small alligator to the ground, like so, okay? And then we'll run these to the screws on the back of the television set. All right, so let's take these over here. And then if we come in the back here, yeah, I know I got two green cables, but we'll keep it straight by size. So the fat one, I'm going to put on the signal right there. Signal screw, okay? And then I'm gonna take the small one and put that on ground down here. Okay? So there you go. So we have our signal going to that terminal per the diagram up here, okay? Because the video input was that, and then the common was that one right there. And then if we look at our connector here, our RCA, the outer ring here is ground, and then the post is signal, okay? And I'm just making sure they're not touching each other, and they're not, so I'm gonna just carefully just let this kind of rest down here, okay? And just make sure nothing's happening. So, okay, so what we need to do now is just power it on, and in theory, what I did here should work, maybe, cross your fingers. All right, let's try it. So let's turn the game on. Now the fan's seized up. Okay, so the tube monitor's warming up. It's funny, our fan's not working now. So let's go in the front here. I haven't turned the NES on, by the way. All right, I'm gonna go ahead and turn the NES on. You guys ready for this? So, please show us something. So the NES is on, and there's nothing on the screen. Okay, now there are some adjustments, I guess. We have brightness and contrast, vertical hold, vertical size. So there's all kinds of pots back here. So in the back, we have vertical linearity, vertical hold, and vertical size. There's 3 pots right next to each other, and I really can't see the screen at the same time. So I'm just going to turn these and see if anything happens. I need to get a mirror because I cannot see what's going on. So I don't know if that's doing anything. So that pot right there, oh boy. So that pot right there is vertical linearity. Okay, and the next one is vertical hold. I'm not sure if that's doing anything. No. Okay, and then the last one here is vertical size.
On your mark.
So I'm not sure if that did anything. Doesn't look good. Okay, and then the other pots are in the front of the chassis. We have sound, brightness, and contrast, okay? And I gotta see if I can get my hand on those. So sound, brightness, and contrast. So I'm just gonna turn these, see if anything happens. So that was brightness, and this one's contrast. So does it look any different or better or worse? So you can see I have my hands down in there. So we don't have any kind of a signal here. So I'm just playing with brightness and contrast. I don't know if that's doing anything different there. What happened? Well, that's not good. Did I do that? Huh.
On your mark.
We lost the picture completely now. Great. Okay, I got the picture back. I guess I turned the brightness down too much. Okay, so there's a switch here. I don't know what that does. What did that do? So that switch there is called InstaView on or off. And it's off. I don't know what that does. So the brightness, as far as I could tell, is cranked, like all the way. So there is a horizontal hold pot. You don't think that the picture is like fluttering, do you? I guess we could try turning it. Let's see if anything happens here. So I'm just adjusting the pots on the back. So I don't know what to do now. I'm curious if we get any sound. Hang on a second. I'm gonna hook up the alligator clips to the speaker. Okay, just out of curiosity here, I want to see if the audio amplifier on this thing is working. So what I did is I hooked up the audio. So this is the audio composite video, or audio RCA from the NES, and I hooked it up to the audio in and the ground over here. So I'm curious if I start a game here of Kid Nicky, if we'll hear it. So the volume pot is right up here.
On your mark.
No, we don't hear it. Nothing. Yeah, I'm pushing every button on the NES controller here. Let's just reset that. No, we're not getting anything here. Yeah, I'm just, the game, I can't see the gameplay, but I'm pressing start and everything, and I'm not hearing any sounds. And let's go back to the volume now up here. Sound loudness on off switch. Okay, that was not good. Holy f***. Excuse me. So, I turned the audio switch all the way off, and it sparked. Because the switch in the front here is also on off, and when I turned it to off, it made a big sparky noise. Something tells me this has not been used in a long time here. All right, let me turn it back on. Hopefully we didn't ruin something here. So
On your mark. Get set.
okay, whew. so I don't know, that was really weird. All right, so already I'm starting to be a little worried. Already I'm a lot scared. So I think that we pretty much determined the TV's not working. I don't know. I mean, isn't it an adjustment? So, assuming the NES signal is compatible with this television set, which I believe it is on paper. I mean, it's a composite video signal, right? And coming out of the NES, this thing's looking for composite video from the board, but we don't see anything. We don't see Kid Nicky. When I hook up the audio from the NES to the audio in over here on the game, we don't hear the game audio. We don't hear the Kid Nicky audio. So what does that mean? Does that mean that the audio amplifier is not working? Does that mean nothing is working in regards to the television set? John's going to be doing a lot of late night research on the iPad, I suspect. All right, so let's put everything back where it was, just so we don't get confused. Okay, so this was the audio input, and everything's off right now. And mind you, I'm being very careful here because this is a exposed television, a very old one with vacuum tubes, and it does scare the hell out of me. So, okay, so the TV does not work. I mean, I think we can assume that, right? What is wrong with the TV? So what are my choices here? Do we take apart the other television I have here, okay? And do we use that chassis? And if we do that, I have to basically figure out the mods that they did on this and replicate them on the new TV, which I think we can do. I think we can figure that out, okay? So I'm just looking here, and let me just make sure this is all unplugged. Because that spark that we got there, that was a little spooky, you know? All right. So everything's unplugged. So let's kind of look in here again. So the wires for the video signal are coming here, and then it's going through here. Let's just make sure everything's connected, okay? And it's coming out of here, and then it's coming somewhere down here on the board, okay? And I don't know where it's going. I mean, we really should remove the TV, okay? So I'm not prepared to pull the TV out today. What I was hoping we would do is at least get the power supply working, because I think that's not going to be too bad. Maybe we should just have some minor victory, which is maybe the power supply. Because I have the rebuild kit, and that's just a function of sitting down and replacing the parts. Maybe we should do that. Let's see if we can have a minor victory at least. Actually, before we do that, let's test the power supply, and let's verify what voltages we have coming out of this thing. So let me plug the game back in. Because if you look at the schematic and everything, this thing is supposed to only have 5 volts. That's all the game requires is 5 volts. So I just plugged it in, but it's not on. So let's turn it on. And so this is our AC transformer down here that's stepping down the voltages that come up here. There's the power switch. Okay, so this looks like voltages in. And these are voltages I see to the fan. Okay, so our voltages are coming in here. And to another transformer. Okay. I see. Okay, let's turn it on. All right, so it's on. Our fan isn't working again. There it goes. Just needs a little nudge and it goes again. Okay, so the fan's running. All right, so let's put this thing on auto voltage. And let's go ahead and test. These two leads right here are, God, I don't know why I'm scared. It's like vibrating because of the fan. Okay, so I don't have anything coming out of here. Let's put it on. It's on auto, right, by the way. So if it's DC or AC, it'll tell me. Oh, there we go. So it's these two tabs right here. Oh, wow, 4.9 volts. Well, that's not bad. It's not under load. So, did I have red here before and white over here? So the power supply is almost working. Yeah, it's 4.9 volts. It's fluctuating though.
What's your mark?
No, it's pretty much 4.9. And there's a little adjustment pot here. Wow, is our power supply working? That was not working before when Ab and I were testing it. We got very low voltage out of that thing. Maybe let me get some alligator clips and maybe we can get some little better connection here. I'm a little shaky with the probes. All right, let's put this one here. And we'll put this one here. Okay. And so the big one's going to be positive, and the little one's going to be negative. So I have the alligator clips going to our meter here. And maybe that'll give us a much... Look at that. That power supply is working. That power supply is completely working. Look at that. That's 4.9 volts. It's working. And the thing is, I can dial it in. There's a little pot here. I bet you I can adjust it to 5. Now, we're not under load, okay? So keep that in mind. So we can't fully trust this thing. But let me just see if we can adjust the pot here a little bit and get it dialed into 5. Again, we're not under load, and you should always, test voltages under load. So let's see if we can just move this pot. So the pot is cranked. It's at 4.9. So it's a little weak. We cannot get to 5. And if I were to just turn... I'm being careful here. I don't want to get shocked. If I turn the pot down... So you can see the pot's working. I can make the voltage go all the way down. So if we crank it all the way, we can get to 4.8, 4.9. So it is a little weak. All right, I think we should rebuild it. Because I can't even get to 5 now. So it's underpowered. And when it's under load, it probably drops even more, which I think was what Adam and I were seeing when we were playing with this before. So, all right, so here's what we're going to do. The game is off. Let me get set up here, and let's pull the power supply off. I think I'll turn the arcade off, and we'll just get to work here and see if we can shotgun this thing. Let's try to have some minor victory today. And at least get 5 volts coming out of the power supply. God, that'd be great. And then I'm going to think about this TV and ways to test it. I really thought I had it figured out with the NES, and I guess that's just not the case. So, all right, let me turn the arcade off, and we'll get set up, and let's rebuild the power supply. Okay, so I want to get the old power supply off here, and it looks like there's 2 carriage bolts here and nuts, and I actually kind of broke them free already just using my hand, and. But then we're going to have to deal with all these wires. So I'm going to have to desolder these wires, but I really need to document what it is I'm undoing. But let's pull these 2 nuts off right here, and let's just see what happens. Does this thing just fall off or what? And yes, the game is absolutely off right now. All right. Okay, so lock washer fell off. All right, so here's the power supply right here. And we have 4 wires. Here's a lock washer. Let's see, 2 go to the fan. And then 2 go to the power. But they're both black. So I want to label this stuff somehow. Let me see if I can just hang this somewhere carefully. So 1 is AC in. and looks like this is AC out for the fan. So line in 120 volts here and here, and then this is looks like a line out to feed the fan. 115 volts it says the fan is. Alright, so let me put these nuts over here. Okay, so I want to disconnect this. Really, I just want to disconnect the power, and I want to label them so I put them on exactly the same way I'm taking them off. I'm just going to carefully just have this hang here real quick. Let me go get something to label this with. Yeah, I know, it's not really a good idea what I'm doing there, but I don't have enough hands. Alright, here's what I'm going to do. I'm going to take some tape, and I'm going to put tape on the two rightmost wires, okay? And it goes black and then white. And then I'm going to take a photo of where they go. So obviously these stay together, okay? So that's black and white. And then I'm going to put a piece of tape on the right one, okay? And I'm just going to take a photo of that so that when I put it together, I know that the black one with the white wire, the black one with the tape goes on the right, and then the black and white are combined together for the center, and then the one that's left is going to go on the left. I just don't want to screw this up when we put it back together. And then let's just take a photo of it. Okay. Alright, so now we know when we put it back together what goes where. So I'm going to take my soldering iron, and we're just going to undo all of these tabs here. And hopefully gravity will just kind of yank them out. Or not. Let's see which one has the most pressure on it. Boy, that stuff's really in there. Maybe we should add a little more solder. I'll get my solder pullet. Well, guys, we're finally doing it. We're working on this damn thing. Oh, this is a really daunting task. I'm not going to lie. It's definitely intimidating. Alright, so I'm going to go ahead and just... This is really awkward, too, because my soldering iron barely reaches over here. So I'm just going to kind of add some new solder. Alright, that one just fell off. The solder's so old, and once we kind of add the new, it really helps it flow. Alright, so that one right here is ready to just fall off. Okay. So let's get this one off. Okay. And we got one more here. This is just so awkward. Yeah, okay. Alright, we got it off. Wasn't the smoothest way to get it off, but we got it off. So, alright, let's bring it over to the desk and let's take a look at it and see what parts we can replace. Alright guys, I have the power supply on the bench here, and I'm looking at it. And by the way, Toth Wolf, he's the guy that helped me put together this kit. He ordered the parts for me, and he sent me this schematic for the power supply. He did tell me in his notes that he included a 10,000 microfarad 16 volt axial, which is this big guy right here. Originally, this one right here was a 500 microfarad 15 volts. He said he included a 560 for that. Now, normally, I would say you can't change the microfarad value, but I'm going to trust him here on this because he says he did include a 560 microfarad 50 volts for C5, and according to the schematic, it should be a 500 microfarad, but he included a 560. I'm guessing it's not going to matter for the switching power. I mean, for the linear power supply, and of course we can check voltages, so we'll know exactly what it's doing before we hook it up to our game board. And then he included a transistor right here that goes on the bottom, and some diodes and a resistor. So what we're gonna do is, well, we gotta take this apart, and I'm looking at it. And by the way, this is the brand. It's an Alexon OLV 15-5. That's the model of the power supply, and it was made by Alexon Incorporated. So this was, again, an off-the-shelf device. But we gotta remove all this stuff here to get to the bottom of this board. And so hopefully I can just unscrew this, and this will all just come apart. So there's that. And then when I unscrew this here, the transformer is going to want to drop out. So I gotta be careful. I don't think this is going to be hard here. It's just a function of finding the parts, and so Toth will have helped me find them on the sites. And then I sent him the cache and he ordered it for me. Alright, so let's remove all this stuff. You know, I was thinking, I went in the garage to get some tools, and I was thinking to myself, well, assuming that the NES experiment that I was doing was correct, okay, let's just assume that the TV was 100% working, then yes, what I did with the NES should have worked, okay? I'm assuming that that experiment is correct and it would have worked. And then the audio test failed, okay, so we weren't able to hear any audio coming out of that. Oh shit, I just dropped a nut. So we had no audio, we had no video. Okay, so does that mean that the TV is hosed 100%? You know, the video portion doesn't work. Okay, so this is soldered in here. All right, so let me... So I cannot take this apart right now because this transistor is soldered to the board and it's holding the whole thing together right now. And as far as polarity goes here, we got to make sure we do this right. And there's a lock washer somewhere in here. I'm not sure. Oh, there it is. Oh, shit. There's nuts and washers falling everywhere. Okay. Okay, so let's desolder this. Again, I'm just trying to observe polarity on the transistor because it does go in one way, and I want to make sure that I put it together the right way. Where's my solder? Pull it. Where did I put that? Oh, here it is. All right, so let's go ahead and just add some new solder to the old transistor, and then we're going to pop this guy out of here. But anyway, to finish my thought there, I'm in the garage thinking to myself, well, I think we kind of established the TV is not working, assuming the NES audio and video tests were both correct, meaning that what I was doing should have yielded the results that I wanted, assuming the TV worked, because the signals I was sending were indeed compatible with the TV, okay? And then I started thinking, well, maybe after we established that the voltage is working, that we find another TV that can accept a composite video source, which I have. I have that PVM monitor down here, which is a CRT. God, I'm kind of butchering this here. This is just awkward. Should probably go get my I was going to say, I should probably go get my Hacko. Let's see if we can get this off now. Just trying to pop this off here. Alright, so the little insulators. This is free. This one leg right here. There we go. Okay, so that's how it goes in like that. I'm just going to kind of keep it there just so when we put it back together, we do it the same way. So is there an insulator? No, that's interesting. There's no mica on here. Or is it underneath? Yeah, there is. Okay. All right, so let's take a look at this thing. It looks a little burnt up. You can see there's definitely some heat damage in here. So I think the obvious thing right now is to just start changing out these components. We'll start with the big obvious guy right there. Let me get my side cutters here. Probably should go in the garage and get my my Hacko desolderer, but I guess we could just do this old school. So let's disconnect that. Okay. Alright, so we want to get this guy off here. And I just want to make sure I know where positive and negative is. And it looks like this side here is positive, judging by the pluses right here. And is it labeled on the board? It's not. Alright, so I'm positive. Alright, so negative is going to be on the bottom and positive is on the top. Boy, there's nothing labeled on this board, so I got to really pay attention to what I'm doing here. Okay, so let's go ahead and just cut. I'm just going to cut these off. And let's see if I have a marker here. I'm just going to go ahead and put a plus on there. Alright, so that's that. Okay. So then we should be able to come on the bottom here and desolder these two leads. And we're just going to add some new solder. And the other lead is over here. So this is definitely the oldest board I've ever worked on. So I just want to be careful. I don't want to blow out any traces or anything. And I can see that the leads are bent over. Which is not good. It makes it always hard to get this stuff out when the leads are bent. Alright. Let's see. Alright, that one's just kind of falling out there. Let me see if we can get this one out. Ouch. Okay. Alright, so everything's free. So let's go ahead and just replace that. And really the big deal here is I observed polarity and I wrote down that plus was on this side. Okay. And so if we look at our replacement cap, yeah, technology's gotten smaller, okay, but it's the same value. 10,000 microfarad, 16 volts, and the one I'm pulling out is 10,000 microfarad, 15 volts. Okay, and if we look on here, negative is here. There's an arrow pointing at it, so therefore this is positive. So let's go ahead and just stick this dude in here. Just like so. Okay. And I'm just going to bend this one back for now just to kind of hold it in place while I do this one over here. So let's go ahead and just heat this up. Add some solder. I'm just going to take my hand here and press the part towards the board so it's nice and flush. And let's bend this one back up. And then let's add our solder. So this board doesn't have like solder mask, so it's like an exposed trace all the way down, and so the solder just kind of flows down it. Okay. Okay, so that's in there pretty well. All right. Okay, negative, positive. Okay, so let's do this guy right here. All right, so I'm looking at the cap here, and I'm guessing that this is positive right here. Plus, 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 plus. So let's take our marker and just write plus on this side. Because if you look at our cap, see it says plus, 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 plus. So I'm assuming that that's the positive side of that cap. I'm just going to come in here and write plus. Alright, so let's get this dude off, which is going to be these two right here. Alright, so I'm just going to go ahead and just replace this one exactly the same way I did the other one. I'm just going to add new solder and then desolder, and then I'll come back. But really, right now what we're doing is pretty simple. We're just desoldering, removing the old parts, and then replacing them with the new correct parts. So I'll go ahead and take this one off, and I'll be right back. Okay, I replaced all the caps now, the two caps. And so I'm wondering now what else I should replace. I'm looking at what he included in the kit. It was a resistor, a couple diodes, and this. So I think we'll do the diodes here, and I'll test them too to make sure they're actually bad. But there's two diodes right here. I'm looking at the schematic, and they come right out of the transformer right here, okay? And you could see the little diagram on here. That is like the flow, okay? See the arrow? So voltage is flowing that way. The diode's kind of like a one-way street. And then here's the modern one right here. And so the band on the diode indicates the direction of the voltage flow, okay? And so everything's going to flow this way, not back that way. And so it's a blocking diode, okay? So the old one, it's flowing that way, and then there's a line above the arrow, and then so the band here, those two are kind of lined up like that. If you can see that, and that's the correct way to put those in. So I think I'm going to go ahead and just cut these off. And then we'll just, I do want to test them too. I am pretty much shotgunning this, right? I mean, I'm not going through the effort of seeing which component is out of spec or anything. But if you wanted to test these, you could. Of course, I cut my leads really close, but here. You have to test them out of circuit, though. You cannot test diodes in circuit, so you got to remove them from the board or remove one of the legs. So let's go ahead and just see if we can test these diodes. And I'm going to put it on diode test, which is this right here, okay? And basically, we're supposed to get a reading one direction and not the other, okay? So let's come in here. Let's see what happens. Okay, I'm just going to carefully put these on here. Okay, I'm getting no reading in that direction. And let's switch them. Okay, so that diode's good. And let's check this one. Okay, we get a reading in that direction. And I'm going to switch my leads, and now I should not get a reading. And we don't. So these diodes were actually good. But I already cut them out, so let's just replace them. I suspect the only parts on here that could have been out of whack, maybe besides this resistor, were these caps, the electrolytic caps. Because usually that's what goes bad with these old parts, is that the caps dry up. But anyway, I'm going to go ahead and desolder these legs right here. And then we'll install the new diodes. So I'll go ahead and do that really quick. Okay, I replaced those diodes right there, okay? And they're big, fat components here. And I also went through here and reflowed the solder here on these joints. This one right here is actually kind of loose, and that's where the transformer kind of dumps into the board right there. Now, the diodes I pulled off, I noticed underneath, you know, they did test fine. At least I was getting readings in only one direction. It might have been out of spec a little bit, but when I pulled the original diodes off, I really noticed, you know, a lot of heat, just signs of heat on the board. Not necessarily damage, but you could just see where all the heat is being generated on this board, and it's certainly those diodes right here. So I feel good that we replaced these. Now another part that's in the component here is this resistor right here, which is a 1.8 ohm resistor, 5 watt. And he sent me a new one, which is also a 0.18. This is a 215 watt resistor, I think. And he's got a 5, there's a 5 watt in here. Now I tried testing this in circuit, and I'm not getting very accurate readings here. I have it on ohms, and if I do it like this, I get 0.4, and if I switch leads, which shouldn't make a difference, I get 0.3. So, you know, the resistors should read the same in either direction. Now our new one is 0.3, 0.2. And I wonder if I can do a higher range here. Oh, it's milliamps. Let's see. Yeah, so it's a 0.3. It's supposed to be 0.18 plus or minus 5%. Yeah, you get the same reading both directions. I'm not getting the same reading both directions on this one in circuit. So I'm wondering if I should replace this or not. I guess we could pull one of the legs off and just test it out of circuit and see if we're getting a reading that's out of spec. So I'm going to go ahead and just remove one of the legs. I'll just add some solder here and we'll just pop it off and then see what kind of test results we get on this. You know, the Super Bowl is starting. I should not be down here. I have a serious problem. Why am I working on computer space? I'm supposed to be drinking beer and eating nachos. John should not be down here right now. We're almost done, though, and I'll go upstairs and enjoy my weekend. All right, let's see if we can pull this off. This board is really fragile. I guess fragile is the right word. I don't know. It's just stuff's really soldered on here, and I gotta be careful I don't damage anything. And so far I haven't. But it's just an old circuit board, you know. And all the leads are bent over, so it makes getting stuff out not that simple. This is loose. Come on, get out. I'm just trying to get this leg off of this resistor here without burning my hand. Come on, get out. It's like almost out. I really should have got my Hacko desoldering iron. Oh well. I'm punishing myself for no reason, not getting it. Alright, come on, get out of there. There we go. Alright, so now we got the resistor out of circuit, so let's test it now. Just curious if we get same results. 0.7, 0.8. It's supposed to be 0.18. Yeah, it's way off. Just for the hell of it, let's 0.2. Why am I getting different results if I switch the leads? It doesn't make any sense with the resistor. 0.3, and then if I switch the leads, 0.5. It almost makes me believe that the circuit here is influencing this still. So let's completely remove this thing from the board. I'm just going to cut it off. All right, let's see how it reads now. If you guys can see that. All right, let's read this. 0.3. It's supposed to be 0.18. 0.4. Just for the hell of it, I'm going to reverse the leads. Hang on, let's try it again. All right, 0.3, 0.4. It's bouncing back and forth there. And then let's just reverse the leads. We should get the exact same reading. Yeah, we do. So 0.3, it's supposed to be 0.18, and then our new one is what? Is it closer to 0.18? 0.7? 0.6? What is going on here? So this part right here is supposed to be 0.18, and the brand new part is completely out of spec. 0.5. All right, I'm thoroughly confused here. Hang on, let's reset this. Put it on ohm. All right, this is supposed to read 0.18. We're getting 0.3. 0.2, 0.3. It's bouncing back and forth. I wonder if there's a way I can see more digits here. Range. Let's try that. So 0.3. And our old one is 0.4-ish. All right, let's just put the new one on, because it was bouncing back and forth between 0.2 and 0.3, which is 0.25. And let's see, where was this? Okay. Right here. I got to actually desolder that. So let me get rid of the old lead here, and I'll put this back in. And then we're just about done. Okay, so we have that new resistor back in. So the only thing left is that transistor that was in the frame here. And actually, I want to show you guys what I'm doing. I'm actually testing it because Tothwolf told me that, you know, the original part is going to be of a higher quality than the new one, and you might as well just leave the original one in there if it's good. And I always forget how to test these. I always have to pull up this website. It's Vetco Electronics. I did look up the part number. This is a 2N3055, which is a NPN transistor, which is negative, positive, negative. Okay, and I have my test up here, basically walking through the test here. And essentially what's going on here is that if you're looking at the transistor like this, it's base, the body is collector, and then this leg is emitter, okay? You see how there's polarity? These two legs are up towards that side of this hole, okay? You can see there's more space between this leg and that hole than there is between this leg and that hole. So if you're looking at it like this, where the distance between this hole and the legs is less than here, the one leg on the left is the base, okay? And then the leg on the right is the emitter, and then the whole frame here is the collector. And again, I have my little cheat sheet here on the Vetco Electronics site. But basically, you want to put this in diode test, okay? And a good NPN transistor, when going positive to base, okay, and negative to collector, should measure a voltage drop between 0.45 and 0.9, and we're at 0.44. I mean, we're pretty much there, okay? And then if we were to compare it with the new part, it's at 0.55. So I don't know. Does that mean it's a little stronger? Does this mean that this is a little bit out of spec because we're on the low end? And again, it's supposed to be at 0.45 to 0.9 volts, and we're getting 0.44. So we're on the low end, and this is more 0.55. So I'm not sure about that. Does that mean that this is a weak part? I'm not really. I think this either works or it doesn't. I don't know. And then you also want to test base to collector. Okay, so positive to base, and then negative to collector. And again, we should be at 0.45 to 0.9. And we're at 0.43 on this one. Again, we're not within spec. It's supposed to be 0.45 to 0.9, and we're at 0.43. And if we compare it to our brand new one, 0.55 almost, 0.547. Now, if we go collector to base, so positive on collector and negative on base, we should get nothing. Okay, we get no reading there. Okay, so out of range. And if we do that again, on an NPN, you should get nothing on that. Okay, let me scroll down. And then if we go collector to emitter, positive on collector and negative on emitter, we should get nothing, and we get nothing. Same thing with the new one. So they both test fine. This one is testing a little weak because it's supposed to be between 0.45 volts and 0.9. It's not. It's a little less. So you know what? I'm going to put the new one on because it is actually really passing the test. I suspect this isn't going to make a difference, but you know what? I have an opportunity to put a new one in, and so I guess we'll just do it. Because again, I think that these transistors either work or they don't. And then if we look at our plate here, there's only one way we can put this on, and I got to remember how I did this. So Tothwolf did send me a new mica or whatever. So here's the original insulator. This is the kind that you'd use thermal paste, and he sent me one. It's like a silicone pad. Does not need the thermal paste, which is a mistake I've made before. I'm not going to make it today, so we're going to just put this on here with no thermal paste. So basically, we're ready to put this back together, and I have to just remember how this goes. So it should go like this, just like so. And I really want to make sure that none of my legs are touching the plate. I don't think they are. So let's put this back together. And then whenever you replace transistors, you got to make sure that the legs don't touch this frame here. And you could see that's why they have these little plastic guys here. That's to insulate it, so that can't happen. All right. So let's put that in there like so. Alright, so we got some lock washers here. And I'm just looking how this goes on here. Because I have to solder that back on. Let's see, there's a lock washer. I don't like how this is sitting, I have to tell you the truth. I think these actually go in here with the screws. Because you could see the... is that right? I could see the lock washer. I gotta remember how I took this apart. I got 4 lock washers. Let me see if there's any clues here in my drawing. So that's the side profile. Nut. I don't want to screw this up. I really do believe these... Hang on, let me do a little research here. Okay, I believe I have it figured out here. So what I need to do is put these 2 screws in here. And where's the other one? So I have the screws going through... Yeah, I'm pretty sure this is it. Like so, okay? So the screws are going through our transistor. Alright, then lock washer, because I could see the lock washer wear on the plastic bushing. Then nuts. And then there's going to be another set of nuts on the top. Yeah, okay, I'm looking at the side drawing too. This makes complete sense. Yeah, this is right. But what's not right is that I somehow lost a nut, and I don't understand how. Unless it's hiding out inside here. I gotta look around, because it should go like this, right? And then this whole thing is gonna go on here. It's like so. And then nuts on the top. And then that's going to give us our space so nothing can touch anything in between there. Yep, that's exactly how it goes together. And then when I tighten these down... So I'm missing one of these nuts, though, because this is supposed to go on here with a lock washer. How did I lose that? Ugh. Alright, I'm going to look around and see if I could find it. Really weird. I don't see how I lost that, though. But that's totally how it goes back together. I don't know. I looked everywhere. I'm convinced that I did not lose this nut and that there was one missing on here. The main thing here is that this thing is attached perfectly well to this plate and these leads are not touching anything. And if we were to use our multimeter here, we should have no continuity, I believe, from the body of the transistor to the frame. Yep. So that means that these screws and the insulator are all working and we're not getting any continuity from here, from the base to the frame, and then these legs are not touching. So anyway, let's go ahead and line this all up. It's actually kind of a slick little design. So this goes on here like so. Yeah, and if we look here, you could see I think that was missing all along, because you could see that the lock washer used to be here, and there's no signs of a lock washer on this side. So I don't know. I'm gonna go with it was missing the lock washer and the nut. I'm gonna put it on the other side though, because it's easier for me to get to. This really doesn't do much. I mean, all the work is being done by the ones underneath. Okay, so now we need to solder those leads because for the transistor. So let's go ahead and do that. And I do have it incorrectly. It is in the right way, not incorrectly. So let's go ahead and solder these dudes, and then that's it. We're done. We rebuilt the power supply. Now, of course, we didn't test or change any of the other components. Just the ones that were identified by Tothwolf, who is an engineer. So I'm kind of trusting him here. And I'm sure I could talk to Ian Kellogg about adding this as a rebuild kit on his site, assuming this is a success. Alright, so we got the transistor in there. Let me just double check my work. It doesn't look perfect to me. Okay. Alright, let's go ahead here. Okay. And then I need to add these screws back in, which I believe go in here like so. And then a lock washer and a nut on the top. Alright, so I'm going to bolt this back together. I'm going to then screw this back onto the cabinet just the way we took it off, and then we'll solder the wires on and test it out. Alright, I have it back in place here. It's just those two carriage bolts. And then I'm going to go ahead and tighten it down with these nuts and the lock washers. And I was able to get these off pretty much just by hand. Alright, so let me tighten this stuff down. And then we got to solder the wires back onto the transformer. And when we originally took them off, though, we got to remember, because I was soldering them down here, and now it's up here. So, let's think about that. I wonder if I should do the soldering first. Yeah, I think I'm going to do that. Let's remove that again. I'm going to get my wire strippers, and we'll put these wires back on first. Alright, so I got my photo out of the power supply just so I can make sure I put the wires in the right spot. And when we're looking at it like that, the black one with the tape goes on the right, and then the white with the tape, and then the black with the tape. So I guess I'll do that real quick. So let's see, we've got these 4 wires. So this one right here goes in here like so. I think we could figure this out when it's in place. It's just going to be the opposite, right? I did strip these wires back and also revealed the little hole. These are kind of funky thick wires too. All right, let me see what we got to do here. Just going to twist these so we can get them in there easily. So that's our 5 volts. This is our fan. All right. Okay, so let's I'm just trying to figure out the best way to do this. Okay, that one goes like that. And then black and white. If you guys can see what's going on here. This is so awkward. I need to get my soldering iron over here. Let's put it right there. Let me get my soldering iron, which barely reaches over here too. All right. And let me get my solder. Okay. All right, so black with tape. Of course, it doesn't reach. All right. So let's just get there. Just gonna kind of pretend this. I stripped these back with my my side cutters. All right. So white goes in here. This is so annoying. This is like just not comfortable. All right, I'm gonna go ahead and solder these in. All right, I'm gonna solder these in, and I'll be right back. All right, I got the power supply back in, and those wires soldered back on. Transformer, it was actually super annoying, but they're all on there. I think it looks okay. This one looks like it's barely on there. I should probably resolder that one. Hang on a second. It's not really on that tab very well. I think I'm going to resolder that one real quick. Okay, I resoldered that one. It's much better on there. So, okay, so I got everything back together. It's all good. We just need to test our voltages. Again, the 5 volts is not going to the PCB. The 5 volts comes out right here. Actually, these 4 tabs here, one's positive, one's negative, and then we also have sense. So there is like a sense mod. This thing does know, it can go out there and sense what the voltages are and then adjust itself, just like the Atari AR2s, but they tied sense to it, to 5 volts. So the sense mod has been bypassed, or the sense feature has been bypassed. Okay, so I guess we'll just plug it in. You know, this is all isolated, so we're kind of, this is kind of low risk here. I do want to get some alligator clips, and we'll test the voltages using the clips. So this side here is positive, and this side over here is negative. So we'll just kind of come and clip right on here. Oops, I just clipped it to each other. So the big one we'll use for positive, and the small one we'll use for negative. And let me get my multimeter here, and we're going to put it on DC voltage. And we'll put the big one on positive. And the small one on negative. Alright, we'll let that hang down and make sure nothing's touching nothing. And we're just going to kind of rest the multimeter on the top up there. Okay. Alright. So let me just make these connections again. Alright. Alright, so let's plug it in. I think the power switch is off, I'm not sure. Okay, so we have nothing right now. Alright, so let's turn it on. Hopefully nothing blows up here. Okay, so look at our voltage now, guys. It's over 5 volts. That's good. So before we couldn't make it go over. God, we were like at 4.8 or whatever. So let me just come in here. I'll dial it down carefully. All right. Well, that rebuild's a success. So I can get to 5 volts here, and then when we put it under load, we'll test it then. So, all right. You know what? We're gonna stop here. The power supply rebuild was a success. That's good. We got 5 volts now. We're using the original linear power supply. So Tothwoof, pal, thank you for the rebuild kit. I think we nailed it. Power supply's working, and we can dial it in above 5 volts, at 5 volts. I couldn't do that before, so that's awesome. So, all right, guys, here's what we're gonna do. We're gonna stop right here. I think we had a minor victory today with this working, and I'm very happy that the power supply is working now. So that is one variable that we have removed from all of this, right? And that's the goal here, is to remove variables. So one variable is gone. That power supply. And then next video, we'll go after another variable. I think the TV, though, is a big variable we have to eliminate. So anyway, all right, here's what we're going to do. I'm going to turn the arcade back on. Let me print some viewer mail, and we'll hang out for a little bit. You guys want to do that? You want to hang out? So, all right, hang on. All right, guys, all cleaned up. I put computer space back in its hole. There it is. Don't worry, though. We will be revisiting computer space very soon. And I have to tell you, I'm very pleased with what happened today because I wanted something positive to happen today. I wanted something, at least something to happen that was good, especially because this is our first video and I didn't know what was going to happen. And I'm very happy that we had a minor victory today. Really, we did. We had a minor victory. We fixed the power supply. We rebuilt it. And I'm stoked. I mean, we got 5 volts, a steady over 5 volts, because before it was like 4.8 volts or whatever, and we couldn't get it over 5, and now we can crank it up to 5.3, 5.4. So when we plug that back into the main PCB, we'll be able to really dial that in. So anyway, Tothwoof, thanks, buddy, for putting that parts kit together for me. It worked like a charm. So anyway, hope you guys enjoyed the video. I'm jazzed. I'm psyched. I'm a little worried about the next video, though. What do we do now? So, I mean, really, what we did today was the easy thing. Oh, let's rebuild the power supply. I know how to do that. So now it doesn't get so easy. I still think, you know, I want to, that whole monitor piece, the television part of this is really bothering me because the fact that we could not get it to work with the NES, I don't know what to make of that, okay? Because on paper, that should have worked. It was composite video signal. The TV's looking for a composite video signal. Now, it was something on the television, and we couldn't see it because the television wasn't adjusted properly. Do I need to pull the TV out and we can really play at those knobs? Maybe. Or is that TV just hosed? But how come there's no audio? That was interesting, too, because we should have got audio using the RCA plug from the NES. We were getting no audio. So is the audio amp bad? Is everything bad about that television? I don't know. So it's curious to me. I'm very curious. I am curious to know if we were to hook up the video signal that's coming from the game PCB to the television, if we were to hook up that video signal to some other kind of TV. Okay, I got the Sony PVM monitor up there that I believe has composite in. So if I were to take the video signal from the game PCB and plug that into the Sony PVM, what would happen? Will we see stars? Will we see computer space? I don't know. I think that's worth trying maybe the next video. I don't know. We'll see. So anyway, if you guys have any ideas or thoughts about what we did today, I'm all ears. Leave comments and let's talk about this stuff. So anyway, really quick, I want to mention that the contest that I was doing is over, okay? And I was giving away some John's Arcade prize packages, which included T-shirts, DVD, signed CDs, John's Arcade shirts, and some of these Ian Kellogg John's Arcade brand parts kits. So I will be drawing those names probably tonight or tomorrow, and I'll be notifying the winners. There's gonna be 3 winners. I haven't picked the names yet, so I'm gonna go into my little software and I'm gonna randomly pick them using the software, and then I'll be notifying all you guys. I'll contact you and ask you if you want an extra large or I think I have XL and 2XL on the shirts. So hopefully one of those 2 sizes will work. I don't have any smaller sizes. And then I'll send you guys an autographed kill screen CD and also some of these parts kits and maybe something else. I'll look around the basement and see if I can throw in some other goodies. But I'll be notifying you guys here in the next day or two. And then also, I do want to remind you, if you go to iankellogg.com, you can pick up these John's Arcade branded parts kits. Ian's using the finest quality parts, rated 7,000, 8,000, 10,000 hours on these caps. They're all individually labeled, which is really nice, and of course they carry the John's Arcade brand, which is a quality assurance. If you see that, you know it's good quality. So yes, Ian and I are partnering. We're doing this together. This is a way to support John's Arcade. And if you go to iankellogg.com until about February 15th, use coupon code John's Arcade. You'll get 10% off your entire order. And he doesn't just have cap kits for monitors. He's got all kinds of parts. And I've been talking to him about, giving him some ideas about adding more parts like buttons and T-molding. And his library of stuff is going to be growing and growing over time. And really great customer service. And so if you want to get these John's Arcade branded kits and other stuff too, go to iankellogg.com and use coupon code John's Arcade. You'll get 10% off your entire order regardless. Whatever you order, just everything, 10% off. So, all right, let's do some viewer mail. And I should be upstairs right now watching the Super Bowl, but I'm not. So let's do this viewer mail. And then I have to edit the video. Anyway, if you want to participate in the viewer mail, you need to email them to me at blackdog7, which is blkdog7@gmail.com. That's blackdog7, blkdog7@gmail.com. In the subject line, you have to put viewer mail, otherwise I will not find it. I search them by subject line. So please put viewer mail in the subject line. The first one is from Damo. Hey, John. It's me, Damo. I was enjoying the Ikari Warriors arcade video pickup the other day and laughed out loud when you found the number of the beast engraved on the back. I know, poor Adam. He got Satan's Ikari Warriors. If you don't know what I'm talking about, go back and watch that video. It's pretty fun. It got me thinking, have you ever talked about Polybius or Polybius, the arcade cabinet that is said to have psychological effects on players, such as amnesia, night terrors, and the scariest of them all, the tendency to stop playing all video games? If it even existed, it was released in '81 and has disappeared without a trace. Would be awesome, an awesome find on Craigslist. I can see it now. Hey guys, we're in the basement, and today we'll be starting episode number 1 of the Polybius Restoration Series. LOL, you're the best. P.S. I need a John's Arcade video every other day, please. Thank you. All right, so yeah, this Polybius thing. Yeah, it's an urban legend, dude. It's not for real. So, yeah, there's this because there's all these stories back in the 80s of arcade games killing people, okay? And, this always happens with a new technology, a new fad, a new whatever, is that there's always something horrible that happens to one person, and they try basically saying that this is the devil at work here, And so people were marathoning video games back in the day. I know, like, Berserk supposedly killed someone. The guy played for 36 hours straight. I mean, could it be that he was up for 36 hours straight, which is why he died, and maybe he was unhealthy? But no, they blamed the video games. And so there's these stories throughout time about games just kind of making people have heart attacks and killing them and making them have seizures. And some of them are grounded in reality, like the Berserk one. But then there's this one, Polybius, which I think is complete, utter BS. So supposedly it was like in some arcade in Portland, Oregon for like a week. And everyone that played it started having, horrible nightmares and seizures and who knows what. So I think it's complete urban legend. I know that it's been kind of part of pulp culture. It was actually even in a Simpsons game. Simpsons episode, the cartoon. There's like an episode where Bart goes in an arcade and they had all these fictional arcade games, and one of them was Polybius. So yeah, I think it's complete and utter BS and an urban legend. And I don't think I can do a video every other day because that might have Polybius type effects on me. So I could have a heart attack. I try to do videos twice a week, so that's the plan. At least one for sure. Next one from Alan. Hey John, I need your help. My Mr. Do upright is in desperate need of an original joystick. I've been searching high and low with no success. I've been checking eBay and Craigslist and have reached out to fellow CLOV members with no luck. what I have discovered is that there are many like me in search of an original Mr. Do joystick, and so in my desperate hour, I'm reaching out to you. Any suggestions you may have to complete my Mr. Do would be greatly appreciated. I mean greatly appreciated. I've enclosed a photo of this elusive joystick. Perhaps it's time for someone to reproduce this joystick. Thanks for your time. Forever grateful, Alan. Okay, so what Alan is talking about is basically a universal dedicated joystick, okay? And there was 4-way and 8-way. And so Mr. Do would have had the 4-way, okay? I don't know if you guys could see it, but it's a rather elaborate joystick for just a 4-way joystick. So as far as I know, this has not been reproduced and it's hard to get. So, Alan, I don't have any answer for you at all, okay? So what I would do, actually, I'll tell you what, make a post in the comments on this video, or if you're watching this video and you can help Alan, email me at blackdog7@gmail.com, blkdog7@gmail.com. If you can help Alan, tell me, and I'll put you in touch with Alan, and maybe we can help Alan get his universal Mr. Do back to all original. But yeah, that